Okay, something I continue to say is that once we learn how to do one confidence interval, it's really just a quick new formula in order to get other kinds of confidence intervals. So we're going to go ahead and learn another kind of confidence interval. So far we know how to do a confidence interval for means using the t distribution, and now we're going to look at the confidence interval for proportions. Okay, this is actually easier in some ways. Okay, so the confidence interval for proportions. So I just pulled this off the web of the Washington Post, I think, just a couple minutes ago. We want to estimate the true proportion of residents who support Mayor Gray's re-election. According to NBC4 poll published 6 days ago, as of this recording, 28% of 1,138 residents polled support the mayor, okay, for re-election. So we're going to use this as our estimate. Okay, let me go ahead and put up the screen shade so I can just really. So we can use the 0.28, the 28%, as our sample proportion. It's not the proportion of all residents. We're trying to find P, which is the proportion of all residents. This is what we'd like to find. What is P? And in order to find that, we're going to use P hat to estimate it. So in the same way that we used X bar to try to figure out what mu is, we're using P hat to try to figure out what P is. Okay. So the proportion of the residents who support the measure is 0.28, and that's going to be our estimate. We're going to use P hat as an estimate for the true proportion of the population who support the mayor. A little redundant there. Okay, so let's go back to what we know about sampling distributions. The sampling distribution of the sample proportion is approximately normal if. Okay, now we've got to be careful here. It's not if n is bigger than 30. That, remember, is only true for means. This is if n times p is bigger than or equal to 10, and n times 1 minus p is bigger than or equal to 10. Okay, the question is that condition satisfied? Now there's a problem. We don't know P. Okay, we don't know P. And what I'm going to tell you about this particular situation is, unlike the situation with means, we can use P hat if we don't know P, and it doesn't really change the calculation. Okay, so in this case we can say pretty confidently, if we don't know P and we need to use P in a calculation, it's really okay to substitute P hat in there and get an answer. So let's figure it out. We have n, which is 1138 times 0.28. Okay, so 318.6. So n times p hat is 318.6. That's bigger than 10. And now we have to check n times 1 minus p hat. Okay, 1138 times 1 minus 0.28, and we get 819.3. That's also bigger than or equal to 10. Okay, so in this case, yes, the sampling distribution of p hat is approximately normal. Okay, all right, move on. The sampling distribution has a standard deviation of square root of p times 1 minus p over n. Okay, as I said before, we don't know p, but in this case, it's going to be okay to use p hat in this place. And the standard deviation is going to be valid. This is different than the situation we had with sampling distributions of sample means. Remember that when we had to use S to approximate sigma, we had this issue, right, where we had to use a different distribution entirely. In our case here, it's really okay to substitute p hat into an equation. Okay, it's okay to substitute p hat into an equation where you need p, and it's not going to change our calculations. Let's move on. Okay, so the sampling distribution is still normal, so the equation for the confidence interval now becomes, I didn't write it in here, I have to do it by hand, our estimate plus or minus z star, because the confidence interval, the distribution is actually still normal, so z indicates normality, times the square root of p hat times 1 minus p hat over n. That's our confidence interval. Z star plays the exact same role, and we use the exact same table in the book to find Z star as we did previously. That table C, I believe it is, where we use the bottom row. Okay, so for a confidence interval for proportions, we always use a normal distribution. We don't ever have to use a t distribution. It's always Z. Our interval, our estimate is p hat, 0.28, and our standard deviation is this computation here. Okay, and everything else is the same. Okay, all right. So here are our conditions. First of all, we need a simple random sample. So that MBC4 poll better have been a simple random sample for this to work. We need normality, okay, which is what we've needed all along. And remember, we need to have n times p hat is bigger than 10, and n times 1 minus p hat is bigger than 10. That's the exact same thing as we had from the sampling distribution case. Independence. We need independence. So we need to know that our sample size is less than 10 times, sorry, the population is more than 10 times the sample size, okay? So when sampling without replacement, as we're doing here, the population needs to be big compared to the sample size. And here's our formula, which is what we just had. If we draw a simple random sample size n from a large population with an unknown population proportion, in our case it was the proportion of people who will actually vote for Mayor Gray, an approximate confidence level, C, for the interval p is p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. And again, z star is the same z star value we had before. This you can use if you need to use the calculator to compute the value. But z star is still that same value. Remember, 1.96, which is approximately 2, would be a 95%. The same value for z. Okay, here's a little summary here. General statements about confidence intervals so far. Every confidence interval is in the form of an estimate plus or minus a critical value times a standard error. Okay, and here's what they are. The estimate in our cases so far, almost every single time, would either be p hat or x bar. Okay, if the value that we're looking for is p hat, then the critical value will be z star. If the estimate we're looking at is x bar, the critical value will be t star. Okay. If we're looking at proportions, then our standard error is this. If we're looking at means, our standard error is this. Okay? It's pretty cut and dry, really. And this is the kind of thing, this actually appears on the formula sheet in a certain form for the AP exam. You do not have to memorize this, but you do need to know how it's all put together. Okay? So, let's finish up that problem we were just looking at. We had a p hat of 0.28, and we had a sample size of 1138, if I'm not mistaken. Let me double check that. 1138. And let's look for a 95% confidence interval. Our conditions are satisfied because the population of DC is more than 10 times this number. We know that the distribution is normal because 0.28 times 1138 is bigger than 10, and 1 minus 0.28 times 1138 is bigger than 10. So our conditions are satisfied, so we can go ahead and write our confidence interval of the form p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. So we're going to have 0.28 plus or minus, and if we're using 95% confidence, the z star value I need is going to be 1.96. Now, this is not a t star problem. There is no such, we don't need degrees of freedom, so we just say 1.96. So I put 1.96 times the square root of 0.28 times 1 minus 0.28 divided by 1138. Okay? Let's go ahead and do it. So I'm going to do 1.96 times, I'll put my square root, 0.28, 1 minus 0.28. Uh-oh, I need another set of parentheses so I get a fraction in there. So I'm going to do second insert. Divided by 1138, and we end up with 0.026. We'll leave it at 3 decimals. So 0.28 plus or minus 0.026. I need to get that right. Okay. So what does that mean? With 95% confidence, we can say the true proportion of people who are going to vote for the mayor, assuming that we had a simple random sample in the poll, with 95% confidence, I can say the true proportion of people who will vote for the mayor is somewhere between 0.28 minus 0.26 and 0.28 plus 0.26. So again, if I actually write that out as an interval, the interval is going to be 0.28, oh, not 0.82, 0.28 minus that number, and 0.28 plus the number. Oh. So between 0.25 and 0.254 and 0.306. So the true proportion is somewhere between 25% and 31% of voters are going to vote for Mayor Gray. And I can be 95% confident of that response. Okay, that's all there is to it. Okay, we're going to go ahead and do some practice in class. Thanks, guys.